Good morning, dear students. In previous lecture, we have done with the infinite series basic concepts, that is root test or Cauchy's root test and D'Alembert's ratio test, as well as we have done some problems based on that root test for convergency and divergency of the series, right? Now let us move to the next concept of this module, that is power series solution and special functions. Okay, now here there are 3 to 4 very important derivations are there. Just we need to expand the result and we need to substitute it back. Very simple concept. Here first one, Bessel's function, or they may ask in this form, obtain the series solution of Bessel's differential equation x square d square y by dx square plus x dy by dx plus x square minus n square into y equal to 0 in the form y equal to a jn of x plus b jn of x. Once again, here sometime they will give with usual notation prove the Bessel differential equation. Sometime they may give in the form of this, obtain the series solution of Bessel's differential equation, that is second order first degree. Here x square d square y by dx square plus x dy by dx plus x square minus n square into y equal to 0 in the form y equal to a into jn of x. That is, here we are getting some expansion of series in terms of jnx we are mentioning plus b jn of x. Okay. Now here first we have to consider the series as x square y double dash or d square y by dx square plus x dy by dx plus x square minus n square into y equal to 0. Call it as equation 1. Here n is positive real constant. Okay. Now first we have to assume the expansion in the form of summation. That is what? Let y equal to summation a r x power m plus r from 0 to infinity. Okay. What we have to assume? Here we have to assume the series solution in the form of y, that is in the form of summation a r x power m plus r. Here a suffix r from 0 to infinity, that means put r equal to 0 first term will get, that is a naught x power m. Similarly put r equal to 1, a1 x power m plus 1. Similarly plus a2 x power m plus 2 and so on up to infinity. So infinite series, right? So we are considering y in the form of this format. Now what and all we require here for the given differential equation? Say y we have chosen already. We need dy by dx as well as we need d square y by dx square, right? Now for this what we have to do? First we have to find dy by dx, then find y double dash or d square y by dx square. That is, we have to differentiate this relation to with respect to x twice. First we will differentiate with respect to x once, then we will get dy by dx. Okay. Now differentiating y, what we will get here? Or y dash, dy by dx or y dash here. Now here the relation in the form of a r x power m plus r. If you differentiate once with respect to x, here a r is constant. What is function power? N. N into function power n minus 1 into derivative of function, right? So what we will get here? Y dash, that is summation r from 0 to infinity as it is a r into m plus r x power m plus r minus 1, because function power n is n into function power n minus 1 into derivative of x with respect to x means 1. So what we will get here? Y dash is summation r from 0 to infinity a r m plus r x power m plus r minus 1. Okay. Now we want second order derivative here. Now to differentiate y double dash, which and all constant keep as it is and apply the derivative rule for the function. So what we will get here? Y dash is what? Summation r from 0 to infinity a r x, here m plus r into x power m plus r minus 1. We need to differentiate it again. Then what we will get? Summation as it is r from 0 to infinity a r as it is m plus r as it is. Now again differentiate this term. Again compare it with what? Function power n. What is the rule? Function power n derivative is n into function power n minus 1 into derivative of function. So what will get here? N m plus r minus 1 into x power m plus r minus 1 minus 1. Just you compare it with the derivative of x power n is what? N into x power n minus 1. Similarly here m plus r minus 1 into x power m plus r minus 1 minus 1, that is minus 2 into derivative of x is 1. So here we have not mentioned it. Now after finding out y dash and y double dash, you have to substitute all the terms y dash, y double dash in the given expression, this one, right? What is y? Summation r from 0 to infinity a r x power m plus r. So wherever y, replace this. Similarly wherever dy by dx, you have to replace y dash term. Similarly wherever d square y by dx square, you have to replace y double dash term. So substituting for y dash and y double dash in expression 1. What we will get? Write the expression. What is that? X square d square y by dx square, right? First term. So write x square as it is. What is d square y by dx square? See, in symbolic form, d square y by dx square or second order derivative can be written in the form of y double dash or y2 or f double dash x. So many notations are there. Here we have used y double dash. So what we have to do? X square into this term. So what we have to write? Summation r from 0 to infinity a r m plus r minus 1 into x power m plus r minus 2. So the first term finished, plus x into dy by dx, right? Equation 1, look into the equation 1 here. See this one, we are replacing in this expression only. X into dy by dx is what? Summation r from 0 to infinity a r m plus r into x power m plus r minus 1. Just we have replaced what is dy by dx. Then what is the next expression? Plus, see here, x square minus n square into y equal to 0. But what is y? This one, right? So, plus x square minus n square into y. Y means what? Summation r from 0 to infinity a r x power m plus r equal to 0. Once again, here everyone should be very careful. First you have to choose y equal to what? Summation a r x power m plus r from 0 to infinity. Now after that we have to take its derivative part, that is y dash, that is nothing but summation r from 0 to infinity is same. Here a r constant as it is, m plus r into x power m plus r minus 1. Similarly, if you differentiate this expression, what you will get? Y double dash equal to, again summation r from 0 to infinity, write this constant as it is, a r into m plus r. What is the derivative of function power n or x power n form? M plus r minus 1 into x power m plus r minus 1 in minus 1. So it is minus 2 into derivative of x is 1. After finding out y dash, y double dash, you have to replace it back in the given standard equation, right? After that, here we have to simplify. How to simplify? Just x square, take it inside the summation sign. Say here, if you take x square inside the summation sign, what you will get? X power 2, here x power minus 2 is there, it will vanish. What remains? Summation r from 0 to infinity a r m plus r minus 1 into x power what remains? M plus r minus 2 plus 2. So plus 2 minus 2 get cancelled, only remaining term is x power m plus r, right? Similarly, simplify this, multiply this x inside the summation sign. So summation r from 0 to infinity AR m plus R, x power what remains? M plus R minus 1 here. Here x means x power 1 here. So minus 1 plus 1 vanishes. Only x power m plus R remains. Now similarly what remains here? Plus. See, if you multiply here each and every term separately, summation R from 0 to infinity AR x power m plus R into x square. That is nothing but x power m plus R plus 2. Okay. Then minus, take minus outside, then n square also constant out, summation R from 0 to infinity AR x power m plus R equal to 0. Just you need to multiply the each and every term inside the summation sign and simplify. Okay. Now that only we have explained here. See here. Summation R from 0 to infinity AR m plus R into m plus R minus 1 x power m plus R, right? Because plus 2 minus 2 get cancelled here. Next, plus summation R from 0 to infinity AR m plus R x power m plus R minus 1 plus 1 vanishes. So remaining term is m plus R, right? Then plus summation R from 0 to infinity AR x power m plus R plus 2 is there, because here x square into the summation of a term. So that x square term multiplied here. And sorry, here one term is missing, that is n square term missing. Here n square is constant outside. Summation R from 0 to infinity AR x power m plus R, okay, equal to 0. Here n square is there. Now our intention is to collect x power m plus R one side and remaining term to the other side. See what we will get collecting. See here x power m plus R, where and all it is present. See here x power m plus R, here it is there. Here also x power m plus R it is there. Here also x power m plus R. So can we collect the first term, second term and fourth term together? What we will get? See, collecting first, second and fourth terms, we have, see, summation R from 0 to infinity is common for each and every. See here, R from 0 to infinity, R from 0 to infinity, R from 0 to infinity. It is common. Even AR x power m plus R also common. See here. AR common everywhere. See here AR, here also AR. X power m plus R also common. X power m plus R, here also x power m plus R. What remains additional? Additional is, see here m plus R, m plus R minus 1. Here m plus R, here minus n square is there. Right? Now, how to write it? Simplify. Here m plus R, here also m plus R. Common. Right? Common. See here. M plus R can we take outside? Remaining term what? M plus R minus 1. And here minus n square is there. Here you missed here. Minus n square. Now if you simplify, what you will get? M plus R whole square minus n square. Right? Plus remaining term you write as it is, because here there is no x power m plus R term. Here it is totally different. X power m plus R minus 2 is plus 2 is there here in the previous this one. You can see here plus 2 is there. That one we have to write here. It should be plus 2. Okay. Equal to 0. Now our intention is to equate the coefficient of lowest degree terms in x to 0. How to equate lowest degree terms in x? What is the lowest degree term in x here? Look at here. Say if you expand this summation, what you will get? Put r equal to 0, you will get x power m. Put r equal to 1, x power m plus 1. Put r equal to 2, x power m plus 2. R equal to 3, x power m plus 3, like that. But in this case, put r equal to 0, what you will get? M power, here x power m minus 2 you will get. Put r equal to 1, what you will get? X power m plus 1 minus 2 means x power m minus 1. Put r equal to 2, then you will get what? Plus 2 minus 2 get cancelled, x power m. So what we have to do here? What is the lowest degree terms in x to 0 for the first term as well as the second term? See, for the first term we are getting from x power m plus 1, x power m plus 2, x power m plus 3 and so on. Why? Because see here, put r equal to 0 because it starts from 0 only, right? Put r equal to 0, we will get x power m. Put r equal to 1, you will get x power m plus 1. So first series it is in the form of that. See, that only we have given here, right? That is for the first series, it starts from x power m plus 1, x power m plus 2, x power m plus 3 and so on, where r is greater than or equal to 2. Now, for this is the case for this one. See here, see, what about this one? Put r equal to 0, it will give us x power m minus 2. Put r equal to 1, it will give us x power m minus 1. Put r equal to 2, then only it will be x power m. So, here x power m directly we are getting when r equal to 0. But here when r equal to 2, then only you can get x power m. So, that's why here we have given this condition for the second case x power m plus 2, x power m plus 3, x power m plus 4 and so on for r is greater than or equal to 2. Okay. Now, here equate the coefficient of x power m. So, what you will get here? Coefficient of x power m of r equal to 0. So, coefficient of x power m means what here? See, x power m, when we will get? See here, put r equal to 0. Put r equal to 0, you will get x power m, right? So, what we have to write? Put r equal to 0 means here a0 x power m plus 0 here into m plus 0 whole square minus n square. So, what is the coefficient of x power m? Coefficient of x power m means the term multiplied with the x power m. So, what and all? A naught, because r we have to put 0, then only we will get x power m. A naught here m square, because r is 0 here, m square minus n square, right? So, that only we have written here. See, a naught into m square minus n square equal to 0. But this a naught we should consider, assume it as it is not equal to 0, because it is constant term, we cannot equal to 0. So, here let a naught not equal to 0. So, what is 0 then? Product is 0, but a naught not equal to 0 means obviously m square minus n square equal to 0. So, m square minus n square equal to 0 means what? M square equal to n square, or m equal to plus or minus root n square, or m equal to plus n and minus n. There are two different roots because it is quadratic expression, right? So, m square equal to n square means m equal to plus or minus here root n square. Root n square is nothing but n. So, plus or minus n, right? Now, let us equate the coefficient of x power m plus 1 at r equal to 1. See here, again equate the coefficient of x power m plus 1 at r equal to 1. Say in the given expression itself, put r equal to 1 here. See, r equal to 1. Then what happens? X power m plus 1 we will get here, right? So, a1 into m plus 1 whole square minus n square. See, that only we have written here. See, a1 m plus 1 whole square minus n square. Equate it to 0. Now, here since we have chosen already a naught not equal to 0, we should not put the same condition for a1 also. Now, let it be, we can equate both to 0. a1 equal to 0 and m plus 1 whole square minus n square equal to 0. But the thing is here, m plus 1 whole square equal to n square can we write? So that if you take the square root, m plus 1 equal to plus or minus n. But already we have chosen here what? In the previous case, m equal to plus or minus n we have already chosen. So, it does not affect so much if you take m plus n equal to plus, m plus 1 equal to plus or minus n. So, here we can neglect this concept because already we have chosen m equal to plus or minus n in this case. So, m plus 1 equal to plus or minus n, it does not make so much difference for the computation. So, neglect this root since we have already got plus or minus n as a root already in the previous case, right? Now, Similarly, if you equate the coefficient of x power m plus r to 0, then what we will get? What is x power m plus r? When we will get x power m plus r, look at here. When we will get x power m plus r, we have to write the same here, right? X power m plus r means same. AR, here what is the coefficient of x power m plus r? AR into m plus r whole square minus n square. This only we have to write. But here it is not the case. Here when we will get x power m plus r, this minus 2 we need to remove. So what we have to do here? R replaced by r plus 2, right? Then only we can eliminate this minus 2, so that x power m plus r we can get easily. Once again I will repeat, here we need x power m plus r term. For this, it is directly we can take, because here already coefficient of x power m plus r is there. That is ar into m plus r whole square minus n square. But here it is not the case. Here we need x power m plus r. For that, what we have to replace? R replaced by r plus 2. So what happens here? ar plus 2. X power m plus r plus 2 minus 2. So plus 2 minus 2 get cancelled. Now we will get x power m plus r term. What is its coefficient? ar plus 2, because we are replacing r by r plus 2. So what we will get here? Finally, we have to simplify it in this form. See here. So what we will get? AR m plus r whole square minus n square. See here, there is one small mistake. Here it should be plus 2. Okay, by mistake we have replaced minus 2. Here it should be plus 2, because x square is multiplied here. X or m plus r plus 2 is there. See here, this one it should be plus 2. Here by mistake we have taken minus 2. It should be plus 2. So to avoid that plus 2, we have to replace r by r minus 2. Okay, here we have to replace r plus 2 to avoid that x power m plus r. To get x power m plus r, it should be r minus 2. So r minus 2, x power m plus r minus 2 plus 2. It should be plus 2. Okay, so replace r by r minus 2. So what we will get here? Plus ar minus 2 equal to 0. So what we will get? Ar into m plus r whole square minus n square equal to minus ar minus 2, because here plus ar minus 2 equal to 0 given. So if you take this side, it will be minus ar minus 2, right? So what is ar here? So ar equal to what? Minus ar minus 2 divided by m plus r whole square minus n square. Now here we need to discuss two different cases. What are those cases? One is m equal to plus n, another one is m equal to minus n. Now suppose here m equal to plus n, then what happens? Suppose m equal to n, then ar equal to what? Minus ar minus 2 divided by what? n plus r whole square minus n square. So what is a plus b whole square? Here n plus r whole square means what? N square plus r square plus 2nr minus n square. So that here plus n square minus n square vanishes. What remains? So ar equal to minus ar minus 2 divided by r square plus 2nr, right? Where r is greater than or equal to 2. Now put r equal to 2 in this, what you will get? Because why we are taking from r from 2 only? Because already we have taken a naught not equal to 0 and a1 equal to 0. We have already taken in this case. You have seen, see here. See here, already taken a naught not equal to 0 for the first case and a1 equal to 0, right? See, a naught not equal to 0, and for the next case a1 equal to 0. So it will start from a2 only, right? To get a2, what we have to do here? We have to start from r equal to 2. Now put r equal to 2, then you will get a2. a2 equal to what? Minus a naught divided by, put r equal to 2 means what? 2 square plus 2n into 2. So what will get? 2 square is nothing but 4 plus 4n. Here minus a naught by 4 plus 4n, or can we write it as minus a naught by Can we take 4 outside? Remaining is 1 plus n. Okay. So we are getting A2. Because A0 not equal to 0, we can express A2 in terms of A0. Now put R equal to 3 in the same expression, what you will get? A3. See here, this is your standard equation. Here you have to put R equal to 2, R equal to 3, R equal to 4 and so on, right? Now put R equal to 3, what you will get? A3 equal to minus A3 minus 2 means 1 divided by 3 square plus 2n into 3. So what you will get here? See, a3 equal to minus a3 minus 2 divided by 3 square plus 2n into 3. That is minus a1 divided by 9 plus 6n, right? But already we have discussed what is a1. a1 is 0. We have already assumed in this case, see here, a1 equal to 0, right? And a0 not equal to 0 already given. So because of that, what we will get here? A1 is 0, therefore A3 also 0. So clearly you can guess here all the odd term vanishes. A1 0, A3 0, A5 0, A7 0 and so on, because everything will ends with A1, but A1 is 0. So because of that odd terms all vanishes. See, that only we have given. Similarly A5, A7 are all equal to 0 because of A1 0. That is A1 0, A3 0, A5 0, A7 0 and so on. Put R equal to 4 in this expression, what you will get? A4 equal to what? Minus A4 minus 2 divided by 4 square plus 2n into 4. That is what? Minus A2 divided by 4 square is nothing but 16 plus 4 into 2n is nothing but 8n. But what is A2 actually? We have proved in the previous slide here. What is A2? See here. A2 is nothing but minus A0 by 4 into 1 plus n. You have to replace it back in the next expression. But A2 is minus A0 by 4 into 1 plus n. So what we will get here? Therefore A4 is nothing but minus 1 by 8 into n plus 2 into minus A0 by 4 into 1 plus n. Just you need to replace the previous value back. See, minus A2 by 16 plus 8n. But A2 is nothing but this much, minus A0 into this much. So you have to replace it back. So 16 plus 8n into 4 into 1 plus n. Here minus into minus become plus. It will be replaced by A0. So that only we have given here. See, minus into minus plus A0. 8 into 4 is 32. What remains? N plus 1 into n plus 2 and so on. Now, when we expand expression 2, what we will get? That is the given expansion. Your expansion y equal to what? Given expression. This one y equal to summation r from 0 to infinity a r x power m plus r. Just to expand it. A0 x power m plus a1 x power m plus 1 plus a2 x power m plus 2 and so on. So that only we need to expand and write it in this form. So what we will get here? See, y equal to a0 x power m plus a1 x power m plus 1 plus a2 x power m plus 2 plus a3 x power m plus 3 and so on. Call it as equation 5. Now, let us choose this y as y1 because we are discussing there are two cases. One is m equal to n and another one is m equal to minus n. Now let us choose y as y1 for positive term m equal to plus n. And substitute all the values a1, a2, a3, whatever the values. Okay. What we will get? Instead of y, we are replacing y1 and instead of m, we are replacing n because we are discussing the two cases m equal to n and m equal to minus n. So put m equal to n, what you will get? y1 equal to a0 x power n plus, what is a1? 0 we have already chosen, x power n plus 1. What is a2? A2 already we have given. What is that? Minus a0 by 4 into 1 plus n and x power n plus 2. Similarly, a3 is 0. Next, what is a4? We have given here. See. A0 by 32 n plus 1 into n plus 2. It should be positive. It should be positive. Into x power m plus 4 plus and so on. Now simplify it. A0 x power n. Here plus into minus minus. A0 by 4 into 1 plus n x power n plus 2 plus, here it should be plus only a naught, because here plus, see, minus into minus we got plus here. So plus a naught by 32 into n plus 1 n plus 2 into x power m plus 4. What is common in this? See here, a naught you can see common everywhere. Even x power n also common, you can see everywhere. See here, x power n plus 2 means x power n into x power 2. X power n, it should be n. So x power n into x power 4. So what is common? A naught x power n common. What remains here? 1 remains. Here, since we have already taken a naught outside and x power n outside, remaining is x square, right? So x square divided by 4 into 1 plus n. Next, x power 4. X power 4 by 32 into n plus 1 into n plus 2. Since we can express 4 in terms of 2 square, so it is 2 square. Similarly, 32 in terms of 2 power 5. So 2 power 5 we have taken. Call it as equation 6. Okay. Now, next let us move to the case 2, that is m equal to minus n. So what we have to do? Put m equal to minus n in the previous expression. What you will get here? See, put n equal to minus n. So, and mention it as y2. So, y2 equal to what happens? A naught x power minus n plus a1 x power minus n plus 1. a2 x power minus n plus 2. a3 x power minus n plus 3 and so on. So, that only we have given here case 2. Okay. Now, y2, here a naught x power minus n common, right? And a1 0, a3 0, a5 0. Only the term containing even powers only remains, x power 0, x square, x power 4 and so on. So when we replace m equal to minus n, what will be the change in this expression? Denominator. See here, 1 minus n we will get. Here also 32 into 1 minus n, here 2 minus n and so on. So that only we have mentioned here. See here. So a naught x power minus n common, keep it outside. 1 minus x square divided by 2 square into minus n plus 1 plus x power 4 by 2 power 5 into minus n plus 1 into minus n plus 2 and so on. Now, the general or complete solution of the given expression is what now? That is small y equal to a y1 plus b y2. Why we took y1 and y2? y1 for case 1, that is m equal to n, and y2 for case 2, that is m equal to minus n, where a and b are what? Arbitrary constants. Now, how to find this a and b? That we have to check here. Now, we shall now standardize the solution as in equation 6 by choosing a naught equal to, see this a naught we have to choose as 1 by 2 power n into gamma n plus 1. You have already studied the expression. What is gamma n plus 1? Result, standard results. Gamma n plus 1 is n gamma n. Gamma half is what? Root pi. Such relations we are using here repeatedly. So gamma n plus 1 is nothing but n gamma n. So that we are using here repeatedly. So what is a naught here? We have to standardize by taking a naught equal to 1 by 2 power n into gamma n plus 1, and same will be denoted by y1. So this expression becomes what now? Therefore expression 6 becomes x power n, here a naught was there before. So a naught replaced by what now? 2 power n gamma n plus 1. Right? So x power n by 2 power n gamma n plus 1, and remaining you write as it is. That is what? 1 minus x square was there and 2 square was there. Right? See here, x square and 2 square. X square, 2 square. So combine that. So what? X by 2 whole square. That only we have given here. Right? See, x by 2 whole square into 1 by n plus 1. Similarly, 2 power 5 is there in the denominator and numerator x power 4 is there. So, I will split 2 power 5 in terms of 2 power 4 into 2 power 1. So, that it will be 2 power 5, right? So, x by 2 whole power 4 into 2 into n plus 1 into n plus 2. Now, what is common you can see from this? Now, here x power n can you take outside and 2 power n can you take outside. So that x by 2 whole power n, can we write it in the form of this? Then remaining, take it inside, 1 by gamma n plus 1 minus x by 2 whole square n plus 1 gamma n plus 1. See here, n plus 1 already there, gamma n plus 1. Next, x by 2 whole power 4, here 4 it should be, its whole power 4. Then what remains? 1 by 2 gamma n plus 1 n plus 1 into n plus 2. But how will you simplify these expressions? See, by the property of gamma function, we have gamma n equal to n minus 1 gamma n minus 1, or gamma n plus 1 equal to n gamma n. It is not root, it is gamma. Next, gamma n plus 2 is n plus 1 gamma n plus 1. One less here. See, n plus 1 means n gamma n. It should be gamma. And n plus 2, gamma n plus 2 means n plus 1 gamma n plus 1. Similarly, gamma n plus 3 means n plus 2 gamma n plus 2. Or can we write it in the form of n plus 2? What is gamma n plus 2? Can we write it in the form of n plus 1 plus 1? So that we can apply the property again. So that n plus 1 gamma n plus 1 is gamma n plus 2. So what happens here? So n plus 2, n plus 1 gamma n plus 1 is nothing but gamma n plus 2. So to use it in this formula, we are using the basic property of the gamma function. So what we will get here? So y1 equal to what? X by 2 whole power n into 1 by gamma n plus 1 and x by 2 whole square. It is gamma n plus 2. Then x by 2 whole power 4, it should be 2 constant as it is gamma n plus 3 and so on. Now this can be further written in the form of what? See, plus minus rule here. So x by 2 whole power n is common. Here minus 1 power 0 by gamma n plus 1 minus x by 2 whole power 2 1 by gamma n plus 1 gamma n plus 1, or x by 2 whole power 4 here. It should be 4 1 by 2 gamma n plus 1 n plus 1 n plus 2, or you can write it in the form of this only, no issues. Now simplify this. What you will get? X by 2 power n summation r from 0 to infinity. Here minus 1 power r divided by gamma n plus r plus 1 into r factorial. There is no gamma here, it is misprint. Gamma n plus r plus 1 into r factorial x by 2 power 2r. See, how will you write this in the form of expansion? Say, put r equal to 0, it will give this one. Put r equal to 1, it will give this one. Put r equal to 2, it will give this one. It should be, put r equal to 2 means x by 2 power 4. Here it should be 4. By mistake it is misprinted. It should be 4. Now what you will get at the end? That is x by 2 whole power n summation r from 0 to infinity, and here there is no gamma, minus 1 power r by this one. Okay. Now take this x by 2 whole power n inside the summation sign. You will get summation r from 0 to infinity minus 1 power r as it is, x by 2 power what? N plus 2r, and 1 by gamma n plus 1 plus r into r factorial. So this is very important result you have to remember. Now here this function is called what? Bessel function of the first kind of order n, denoted by jnx. Suppose if you further replace m equal to minus n, so it will become j minus nx. So you can change the first sentence of your given question. It should be j minus nx. Okay. A j nx plus b j minus nx. So which is denoted by what? Similar case, if you put m equal to minus n, then what you will get here? J minus nx you will get. Hence the general solution of the Bessel equation is given by what? Y equal to a j nx plus b j minus nx, where a and b are arbitrary constants and n is not an integer. It may be real also. Okay. So this is nothing but the solution of Bessel's function. Okay. Now let us repeatedly work out with this problem. This proof is very important. Some small minor mistake is there in the plus n and minus n. Make it correction. Okay. Here, and one more thing here, j minus nx, that is the first mistake, and one more x by 2 power. Here it should be 4, and here by mistake it is gamma misprinted. Make that 3 corrections. Okay. Thank you dear students.